Welcome to part 2 of the house build. In this episode, we're going to be talking all about radiant heat, specifically radiant heat in the concrete slab. Now, we also will be putting radiant heat in the entire floor of the house, but that's going to be later on, so definitely stick around. In our last video, we left off having fixed the plumbing that was installed initially too high. Once that was finished, I notified my flatwork guy and they came out to lay down the gravel that would go underneath the radiant heat insulation. Real quick, here's a slight example of where plumbing that's installed too high can get in the way of the heat sheet panel. But luckily, I think this was the only section. By the way, if you haven't watched the first video yet, I highly recommend it. But if you're just here to see how we installed the radiant heat for the slab, then by all means stick around. Now, what is radiant heat? That's a great question. To explain it in a simple form in the context of a house, specifically what we typically do in North America, radiant heat is the way of heating your house, whether for comfort or for actual heat, through the form of carrying something hot through something. In our case, it's water. It's called hydronic heat. So we're carrying hot water through these PEX tubes that goes through the floor heats up, heat eventually rises and makes your house warm. Now, I know that's a very simple explanation, but it at least makes sense why we're using thousands of feet of PEX tubing in our house. You might notice the pier pads, which are these square concrete areas that are now indeed more of a square shape. And structurally, it doesn't really matter what shape they are, but it sure does make it easier when installing rectangular shaped insulation sheets. And again, I just wish I had made the foundation guys form up those pier pads to begin with. But I digress. So the flatwork guys finished laying down the gravel and compacted it real nice and flat, which now meant that it was our turn to start installing the radiant insulation sheets. Here we are with the biggest load of heat sheet panels ever. Now, I will try to explain exactly what the heat sheet insulation panels are best known for later on in this video. Since we weren't going to be able to begin the installation immediately, we stashed all of the bundles of heat sheet in the shelter room of the basement.
Incredible walkout view. People, look at this view. Never mind those neighbors.
Tell us more. We had originally wanted to start on that corner, so we distributed the bundles around, but actually, as you'll see here in a moment, we switched over to the other side of the house. See, the way these panels lock in, you have to work a certain direction in order for them to lock into one another. Of course, some of the panels had damage on them, and usually we would just set them aside to be used in areas on edges that needed to be cut off anyway. I found that the easiest method to cut the panels was using a jigsaw. We also discovered that you constantly need to adjust the level of gravel underneath the heat sheet panels to prevent high spots or low spots. Later on, I would find out that using a push broom on the gravel is a great little gravel leveling tool, actually. You'll notice that on the walkout edge of the basement, we decided to leave a gap of about 12 inches or so, where there would be no insulation at all. That gap was essentially the thickness of the trench footing underneath. It would all get filled with concrete eventually. Now here's an example of where having a square pier pad makes the installation a whole lot easier, but even then, I would come back, you know, around the gaps and spray foam and fill in all the gaps around the concrete pier pads. Overall, I think it took us a couple of days to install all the heat sheet panels. The most time-consuming part is cutting around plumbing and the edges of concrete, but once you get out in the open, it's super fast. The leftover bundles of heat sheet would be used for the garage slab, and we used them as paperweights because we were really afraid that we'd come back some morning and find the wind had like blown off all the insulation. I mean, you know, it'd be a pretty bad day if you're driving to the house and you see chunks of very familiar white insulation in someone's field and you're not even at the house yet. Thankfully, that didn't happen. The next step of the radiant heating would be the installation of the manifolds and the PEX tubing. Now let me just butt in here and give you guys a better explanation of what's going on with our system. So we are, first of all, using obviously PEX tubing to create, to transfer the liquid through the house. For the most part, we used 1/2-inch PEX tubing. There are two types of PEX that are typically around in this sort of industry. It's PEX A and PEX B. In summary, the difference is that PEX A is an expansion type tubing and PEX B is not. It's a sort of a crimp style. And one other benefit of PEX A is what I'm doing right now. So I have intentionally created a pretty nasty kink in the tubing, and I obviously did this on purpose right now, but this actually happened to me by accident when I was installing the tubing through the floor joists, and I kept tugging on it and it wouldn't go, and it turns out there was a huge kink in there. And I kind of panicked at first, but then I remembered there's a trick. PEX A tubing has this sort of memory thing about it where if you create a kink like this, you can take some kind of heat source, probably not fire, but let's say you have like a heat gun or something like that, or like a blow dryer. And if you heat up that kink, you will start noticing that slowly but surely, the kink is going away and the tube is going back to its original round form. It's a pretty cool little trick. And hey, guess what? You don't have to cut out that kink and replace it with a healthy piece of PEX tubing. The other benefit of PEX A is the expansion part that I mentioned. So I've got a fitting right here. This is a 3/4 inch PEX. This is sort of a debatable benefit, but in general, when you expand the PEX tubing, what it does is it allows the fitting that you're placing into it, whether it's a 90-degree fitting or some sort of connection, it allows the fitting to remain at the same inner diameter as the PEX tubing. So think about, you have all that water flow, it's hitting a fitting to change directions, and the fitting is not smaller in diameter than that water is already going through. And so that is kind of a cool benefit. With PEX B tubing, you actually put a fitting that's smaller and then you crimp around to create a watertight seal. Now, to be specific, we are using Rehau's products in this video, in this house build, actually in general. So there are many options out there, and for radiant heat specifically, Rehau is just one of the big names. You basically have a whole ecosystem. You have the manifolds, you have the tools, you have the fittings, and they specifically use a fitting that is called the Everlock fitting, which is basically what that sounds like. It's ever-locking. It's easy to use, it's very comfortable, and definitely something that puts you at ease when you know you're going to bury it in 4 inches of slab later on and never get to it again. The other thing is you need to plan the whole thing out, and there are tools for that. One of the most common tools that I think is probably used for radiant heat planning is called LoopCAD, which is probably some kind of extension of CAD, basically, where you are able to use your house plan and use the software to allow you to determine where all of your PEX tubing is going to go, your zones, your circuits, everything. And the whole thing knows that you have a maximum length that you can run. For instance, for 1/2-inch PEX tubing, you don't want your circuit to be more than about 300 feet long, because then you start running out of heat. It's too long of a cycle. So it accounts for all of that and then basically just gives you a finished product that you can tweak and move around to get what you want. So here we are on a nice breezy day starting on the first zone. We begin by mounting the designated manifold. The idea is that you can only relocate this thing down, since your PEX tubing can only be shortened, not extended. So we made sure to err on the height rather than on the lower side. Now you also need something that will route the PEX tubing up and out of the future concrete slab. We are using this thing called an easy route. It can come in many arrangements, but it essentially acts as a sleeve for the tubing to protrude out of the concrete slab that will be there later. By the way, notice that the pucks on the heat sheet panel have been trimmed off to let the easy route sit flush on the insulation. I found that the best tool for this was an oscillating tool with a longer wood blade. So this is one of the primary benefits of using the heat sheet insulation panels. The pucks that stick up are sturdy enough that you can actually walk on them, but they also allow you to insert the PEX tubing in between each puck and follow your layout. Once the PEX tubing is inserted between the pucks, it's snug enough that it won't pop out on its own. And the spacing of the pucks allows you to very easily follow a 12-inch spacing on your PEX tubing, which is apparently the most common spacing when it comes to concrete slabs. I'd recommend having one person guide and insert the PEX tubing, like I did, while another person holds the roll of PEX and slowly unwinds it as you loop back and forth. One important thing to note is that on each zone on the basement slab, there needs to be a separate piece of PEX tubing sent somewhere in the middle of that zone area. That dedicated PEX tubing will become a sleeve for a future slab sensor that will get connected to the thermostat for each specific zone of the basement. The sensor is more or less just a low voltage wire that you're sending down, and of course that PEX tubing is capped off. When all was said and done, we had installed 3 zones that used up over 2,000 feet of half-inch PEX tubing. Here you see me cut up some strips of insulation that will get glued onto the edge of the foundation so that there's a small thermal bridge barrier between the slab and the foundation walls. The next thing was to attach all of the loose ends to the correct manifold station. What's important here is that I had taken the time to label each end of the PEX tubing so that I knew which end was going to have water going out and which end was going to have water going in, and of course which circuit it was. In the example here, you see me working on a 5-station manifold, meaning it is supporting 5 separate circuits that make up one large zone. Each station has PEX going in and PEX going back out. And in case you forget, you can simply blow into one of the ends and you should feel air coming out of the other correlating end. Now we were rushing to get this all buttoned up so that the flatwork company could come out and pour the concrete basement slab. But while I was working in the basement of the house, I heard some commotion out front, and to my excitement, the electric utility company was out to connect our temporary power. So they put a transformer on there.
Yep.
And then from there you have a cable coming to here.
Yep.
And then in the future our main power is going to go down from that same transformer and...
Yeah, are you going underground, I assume? Yep. This will go away, obviously, and then go over to your house.
Yeah. Okay. Will it work? So when you're doing your pressure test with a Rehau gauge, this is a brass fitting probably, you do want to use PVC, or I mean Teflon tape, because it's a little confusing. When you read the instructions on the manifolds, all of the other connections are special threads that do not require any kind of thread sealant, putty, or tape. So they kind of specifically warn you not to use it. But when you're using the temporary pressure test gauge, it may actually leak if you don't use a sealant. So I've come back and I've brought some Teflon tape with me. This is just that real simple stuff from any hardware store. Wrap it around the threads on the brass and then tighten it back up to where the gauge is looking at you so you can easily see it. And it's been successful so far, no leaks. I also had to tighten the Schrader valves on all of these. For whatever reason, they were leaking, but that's not a big deal. You just need a special tool for Schrader valves, or a valve stem tool. Slime makes one from any, tire repair kit. Basically just goes in there and tightens the valve up so it doesn't leak. So now I've got the compressor with me, and I'm going to pressurize all 3 zones. Each manifold is a zone. You can pressurize it to about 50 psi for a test. There's a lot of information online, but it sounds like 50 is the typical go-to psi. Typically when you do the concrete pour though, you want to keep it about 30 psi. And then of course if you have a leak somewhere, hopefully it doesn't happen, but that leak will be pretty easy to find because of the pressure in the PEX tubing. It'll start bubbling out. So we're going to pressurize all these zones. They actually have a little bit of pressure in them, like 30 psi or 25, but like I said, we had some leaky Schrader valves and I didn't have Teflon tape. So with that now, whatever pressure I put in should in theory stay. And really there weren't any leaks, like I said, other than the threads on the pressure test itself, which is kind of ironic, but that's just something that's easy to fix out here in the field. So here I am at 40 psi, and I went ahead and closed this valve off. I can keep it open. The only problem with that is if you come back and the pressure falls, you're always going to suspect that there's a leak here. So if you close it and then come back to check, just open. Well, first of all, if the pressure falls here with that closed, then there is a leak here. So in that case, when you open it again, it'll pop back up to the correct pressure, and that's how you can get a pretty accurate reading. If there is no leak here, then of course keep this open, but I like that extra layer of security. That way I'm only testing the PEX tubing and all my connections on the manifold. You know, never in my life was I so nervous about it raining. And I mean, after days of delays due to the rain, we finally had a break. Although even then you can see some rain in the horizon. But I was ready. While the flat work crew was doing its job, I was doing my job by monitoring the pressure gauges on all of the radiant manifolds. If there was a puncture anywhere, this would be the only opportunity to repair the leak before forever saying goodbye. And you can't just fix a puncture using the old heat trick like I showed you in the beginning. You actually have to cut out that damaged section and press on a new section of PEX tubing using whatever method you've chosen for your PEX installation. Thankfully, I did not have to tread into that wet concrete because the pressure was absolutely steady. You'd never know just by looking at the slab that there's several thousand feet of PEX tubing underneath, along with an entire layer of insulation. But I can guarantee you that when someone walks barefoot on the slab when the radiant heat is on, they will certainly notice something pretty awesome. Before we wrap up part 2 of the house build, I want to show you briefly how we capped the outer edge of the basement slab to create a thermal break. This is 1.5 inch foam. Actually, no, this is 2 inch foam. And we are using 15 psi because it's not bearing any load. It's just a sandwich between the basement slab and the patio that they're going to pour. Thermal break. Okay. The foam would then get capped with some aluminum flashing and finally an extra layer of fiberboard to create the look of a concrete foundation below the future siding. Well, that's about it. We'll see you all on the next video where we actually get to start framing.